Hey, so I've been working on some extensions to my math graph theory tool, and I've recently built one about logic gates. So what I'm going to do here is demonstrate De Morgan's law using the logic gates tool. Let's see, how many nodes am I going to need? I'm going to need a couple of inputs to an and an output. And then I'm going to need a couple of inputs down here to build an equivalent circuit using 3 knots and an OR, so it looks like I am one node short. Let's add a node by clicking here, and the node right now it just randomly appears somewhere in the current square that you're looking at. So I say current square because if you click this where it says group select, you can change to move screen, and you can actually drag the screen around. But for now, I'm going to use group select because that's going to be more useful to me here. So these nodes on the far left I'm going to have as my source nodes, and right now I'm going to change them all to sources off. And then on the end here I'm going to have this one be a sink, and this one is going to be a sink, and as you can see, set type to sink. When there's no signal coming in, the sink just has a dash. And then this is going to be my AND node. So let me select AND here, and you're going to see that by default it shows the symbols, the circuit symbols. So that's what a symbol for an AND would look like. You can change to words too, though. So clicking symbols will change it to words, and now it just says AND. I think I'm going to use words for now because that's a little more clear what exactly these things mean. And I'm going to take this AND and connect it to the sink. And since it's not connected to a source of any type, you'll see that the edge here is grayed out. And then I'm going to connect this off to the and this off to the and you'll see that they're black, and that means that there's no signal coming through. And so since no signal comes to the sink, it outputs as 0. Now if I turn these on, then their signals turn red because there is a signal passing through there. And an AND will pass the signal through only if both signals that it's receiving are on. And so it passes through 1. And so if I click a node and click it again, it disconnects everything from that node. You'll see that although it's receiving a signal here, it's only got one input, so it's not really connected as a valid circuit. And then I can connect the on back on. And I've also got this built so that it will only let you make circuits that make sense. So for example, if I try to connect this off also, it just doesn't do anything because an AND only has 2 inputs. The only caveat to that may be that you can have as many outputs as you like. And that's just so you don't have to use splitters, although you could use one of these blank nodes as a splitter if you like. It'll just pass through a signal, I believe, whatever its input is. Oh, you connect there. Yeah. Okay, so let's disconnect these. And down here we want to use only the logical operations of NOT and OR, but we want to build something equivalent to the AND. So the way we do that, if you're not familiar with De Morgan's law, it's that AND is equivalent to, well, A and B is equivalent to NOT, the quantity of not A and not B. So you can think of the 2 inputs as an A and a B. I should maybe demonstrate that if one of these is off, no signal goes through. And so what we want to do is, well, we're going to take whatever happens in here and do not the whole thing. So our last operation is not, because it's not the quantity of not A and not or not B. And so these are also going to be nots. So we're going to do not A and not B, and then we're going to do either one of the, or on those 2 outputs. So not A or not B. So this one is our OR. And then we're just going to link it up in order. So this is where our sources are going to go to the knots. And as I said, you can't add more inputs. The knot only takes 1 input. And then the 2 knots are going to connect to the OR. And then the OR is going to output to this knot. We're going to negate the whole thing. And that's going to go to this sink. And since the signals are off, it outputs a 0 because it's receiving no signal. If I change one of these to on, you'll see that the on gets negated to off. This off gets negated to on. It's an OR. So this one or this one. one of those is on, so the OR passes a signal, but then it's negated here, and it outputs a 0. However, if both are on, then the output's a 1. So this demonstrates De Morgan's law using logic gates. And if you're not familiar with the topic of logic gates, this is actually the logic of circuits that's used to build your computer. And if you're not familiar with De Morgan's law, you can actually go and learn about it in a lesson that I have in the math, so let me just go there to show you. I click on MinStem to go back to the home page, and then it's under my mathematics, and if you go to logic, it'll be under the third lesson, analysis with fundamental logic operations. So let's see, we've got order of operations, some basic properties, distribution, and here we go, De Morgan's law. Well, this is saying not P and Q is equal to not P or not Q. So if you were to negate both sides again, the negations would cancel on the left. You'd have P and Q is equal to not the quantity not P or not Q. So I don't know if that's shown in the exercises. Yeah, there's some exercises here. We can check your understanding. Oh, and an image missing down here. I'll need to fix. If you're not familiar with all these symbols, because it looks like a lot, this is the third lesson, and they're pretty simple. It just means and or and not. So you can actually go back. I think this is truth tables and what these symbols mean. So go back to lesson 1 if you need to and start from there, and click open the video. You can get a lecture. Go through the lesson, check your understanding at the end just to make sure you're following. And probably by lesson 3 you'll have enough to go back to the logic gates. So you go back to the home page and go into the graph tool. You will have to sign in to get to logic gates and flowcharts. But in the logic gates, then you can come in and try to build these things. And I should have shown De Morgan's law with the symbol. So there's your and. We've got not, and nor, and so on. So you can also build these diagrams with the schematic symbols.